Okay, sports fans. I mean math fans, really. I wanted to start with this particular question, number 9 in the 5.3 notes. For some of you, we got this problem done in class today. Others, we did not. So I just wanted to touch base with everybody so that you understood what we're doing. So let me get my writing tools on board here. I don't know why I didn't do this sooner. Whoops. So, in this particular, on this particular slide, we were doing something called chunking. I know, fancy term. Actually, kind of stupid in my opinion, but that's what they call it. We have a polynomial that does not have, and maybe I should type that out. What I noticed in this particular question is no GCF for all terms. Okay, so maybe I should put that in there. No GCF for all the terms. Okay. So with that being said, and here, let me see if I can slide this up just a little bit. With that being said, when I notice that there's no GCF for all the terms, then it's time for me to do something different. So I lumped these two sections together in the first group and then the second group. And as you can see from number 1 up above, it says separate into 2 pairs. Well, after you do that, then you look for a GCF in each pair. So the first one had an x squared, the second one had a 2. So literally, as we've talked about this before, we can divide each one of these by x squared. Come on, write it out. X squared, and then divide each of these by 2. And what happens when you do that, when you pull out the x squared out of the first 2, you're left with x plus 9. And when you pull the 2 out of the second 2, you're left with x plus 9. So one of the things I said in class for a couple of your classes was, what do these 2 blue boxes have in common? And what I was hoping you'd say is, well, they both have an x plus 9. Well, so what happens when you pull the x plus 9 out of each of those boxes? Well, if you pull the x plus 9 out of the first one, all you're left with is x squared. If you pull the x plus 9 out of the second one, all you're left with is plus 2. So this is the final factoring for that particular question. X plus 9 times x squared plus 2. So separate it into 2 groups. Find the GCFs for each group. Pull those 2 GCFs, one out of the first group, one out of the second group, and then look inside the next part and see that they both have the same parentheses, and that parenthesis is going to come out. It's kind of an interesting question, how chunking works, but you're basically using the distributive property to separate and allow you to find the factoring. You won't see this in everything, but you will see it in some of the stuff, or at least a couple questions. I might have one of these on the test, okay? But that would be it. Okay, let's move to the next slide. Clear that all out. Okay, on this next one, we're going to do this in a couple different ways, okay? Now, no matter which way we do it, first on our list is move that constant number to the other side. Okay, so by doing that, we now have x cubed minus 2x squared minus 19x plus 20 equals 0. Okay, by basically adding the 20 to both sides, that would cancel that out, leaving you with 0 on this side. Okay, So first, move the constant over. Maybe I should type that. Constant over. Okay? Graph it. I'm going to have you do this a couple different ways, but hopefully the graphing would help you a little bit. Okay? X to the third minus 2x squared minus 19x plus 20. That might be a little bit hard to see, but remember how I talked to you about pinching and grabbing, putting two fingers on the axis and it changes color, and then you're able to move it around and see things on screen. The zeros, remember how the zeros are the important part? Okay, so that graph can give you information about the x-intercepts. Those are important things. Okay, so if you can see, hey, I've got one at -4, I've got one at +1, and I've got another one at +5, you might actually be able to factor that pretty quickly. Okay, but there's another technique I also want to show you called synthetic division. Synthetic division. So I'm gonna clear this off, and I'm going to use the down arrow at the top and kind of close that that graphing part. Okay, so when you have something like synthetic division, you're going to have a hint. The question will say something like hint 1 is a 0. Okay, you have to have a hint to start with. Otherwise, you won't know what to do. Now, it's true, you have to move the constant over. But we could change this from graphing to use the hint with synthetic division. Okay, so what does that look like? All right, let's work this out. Change our colors here just for something different. Okay, now, mind you, I had to get everything on one side, get the 20 over to the other side first. Synthetic division, I'm gonna show you how I set it up. I'm gonna put a little box here for a second, and I'll put a number inside there in a second so you'll understand. But I want to write out all the coefficients. Coefficients are the numbers in front of the different terms. So we have 1, -2, -19, and +20. Okay, those are the leading coefficients, the coefficients of all the terms. Okay, now I'll use different colors so you can see. I'm going to draw a vertical line there, and I'm going to draw a horizontal line here. Now you can see that I left some space underneath the 1, the -2, the -19, and the 20, like a whole row of empty space. And I'll show you why in a second. Synthetic division will help me to factor. So this is another way to factor, but you have to have a hint. Now I actually saw the hint that I gave you on the graph that I was looking at. But the 1 is going to come inside this box. Since 1 is a 0. Now, if 1 is a 0, remember it says right here, the real solutions are 1 better be an answer on your answer line. I mean, come on, folks. If you don't use the one I give you, that's kind of bad. All right, so first things first. Let me type this. Okay. But after setting up coefficients and the hint, carry down the first number. All right, so the first number. So what do I mean by that? I mean, I'm going to draw an arrow on screen so you understand what I mean. The first number gets dropped below the line automatically. Always, always, no matter what that number is, you drop it below the line. Okay? Whoa. I have to clear out my hint. Hopefully that doesn't mess people up. My hint disappeared. I guess maybe I'll write it over again. Hint 1 is a 0. Is a 0. All right, now we're going to go through the process of multiplying and adding. So I'm going to take this 1 times this number down here. I'm actually going to multiply these together. And whatever number I get, I'm going to write it above the line underneath the next number. So I'm in the next column over. Okay? And now I'm going to add down the column. Well, what is negative 2 plus 1? That's negative 1. All right, now I'm going to repeat this process over again. 1 times negative 1. Write it above the line in the next column over. Add down the column. Multiply. Write it in the next column over. Add. Now, what did we just find? We just found, let's, no, we're going to leave that alone. We're going to come back here. We're going to pick a different color. The final number in our synthetic division is called the remainder. The remainder is how much is left over. Well, guess what? We know that this can be factored. We should have gotten a remainder of 0. Why am I not? Oh, that's why. Nope, that didn't work. Remainder. There we go. So what is this stuff right here? Well, this is your constant. This is your linear. This is your quadratic. Now you're probably wondering what I'm talking about, and trust me, I'm going to keep explaining until this makes more sense. So, a constant, well, that's just a number. But the linear is negative 1x. And the quadratic is positive 1x squared. So, you were told that x minus 1 is a factor. Now, you might not think you were told that, but at the very beginning of this problem, it said that 1 is a solution. 1 is a solution. Well, you and I both know that goes with x minus 1. And yes, I know you need to practice this until you get the hang of it, synthetic division. But quite honestly, it's multiply, add, multiply, add, multiply, add until you get done. I am more concerned about the interpretation. Now, you'll also see that when I did this, I started on the right side, and then I moved to the left. Now, the reason I did that is because you will make fewer mistakes if you go from right to left when you do your interpretation. Now, is this something you can continue to factor? Well, sure it is. right? We know we got x minus 1. What kind of numbers multiply together to give me negative 20? So multiply together to give me negative 20. And add up to negative 1. Well, I'm hoping you'd say x and x minus 5 and plus 4. So what are the zeros? Well, there's obviously 1, but I gave that to you in the beginning. And then there's 5, and then there's negative 4. Those are the answers to this question. 1, 5, and negative 4. So I want you, when we get to practice together, we're going to practice the synthetic division. You're going to be given a hint. You're going to have to set it up and then carry down the first number and then multiply, add, multiply, add, multiply, add until you get done. Okay, now, I know that synthetic division stuff was extra a little bit in this particular case, remember? Because the question said, can we do this by graphing? Didn't we graph it at the beginning? And man, my whole graph disappeared. Dang it. Well, if you go back at the beginning of the video, you'll see that it had everything we needed. Okay? Now, can you do the next question, find the real zeros by graphing? Well, I'm guessing you won't want to use synthetic division when you have such a nice tool like graphing. And I understand that, but eventually I'm going to take that away from you, and then you're going to have to use things like your factoring techniques, which involves synthetic division. Okay, so now that I've got it entered in, let me click on the arrows and take a look at it. And I'm going to pinch the Y and bring it closer so that I can see what we have here. And it looks like we have 0, 1, and 5, right? You've got 0, 1, and 5. Well, what do you get from, if you know that 1 is, actually, they only asked me for the zeros, didn't they? That's it. That's all they asked me for. Well, that's kind of neat. And now you're like, neat? What do you mean by neat? Okay. So, we already know some of the answers here to this question. We didn't have to do any of that synthetic division for this because I just introduced you to the synthetic division, basically. 0, 1, 5. Now remember what I taught you the other day. Look for a GCF, and you can pull out an X. So this should look familiar to you as well, right? And then we would talk about factoring it and things that multiply together to give me 5, but add to negative 6. And you would choose negative 5 and negative 1. And then you could easily see 0, 1, and 5 from that. All right, let's see what else we can do with the next question. We'll go to the next slide here. Graph the function to find the zeros, okay? Rewrite the function in factored form. Okay, so since we're using a graph for this question, let's go straight to the graph and see if we can do this quickly. 2x squared plus 3x minus 5. Okay, let's go see if our graph gives us enough information from that. Wow, this is different. What's this one? Negative 2.5 and positive 1. Negative 2.5 and positive 1. So the zeros are negative 2.5 and 1. So what would the polynomial look like in factored form? Well, it's probably pretty easy to tell that this one would come from x minus 1, right? Remember we talked about this in class. Here, let me reduce that down. If x is equal to 1, then you could subtract this to the other side, and x minus 1 would then be equal to 0. This is where you would find your factor. So that's the first part of it. Well, what about the other one? How do I get the other one at negative 2.5? Well, if I use that same trick, x equals negative 2.5, I'm pretty sure you're going to say, well, Mr. Staley, why don't you just add 2.5 to the other side, so that'd be x plus 2.5 equals 0. And there's your factor, right? Almost. If you'll look at that particular polynomial up there, it doesn't have any decimals in it. And I'm pretty sure if we just used x minus 1 and x plus 2.5, we would get decimals. So we are going to modify this a little bit. We are going to multiply this. What are we going to multiply it by? Well, another way to say 2.5 is x plus 5 over 2. So how do we get rid of the denominator? Lots of you don't like denominators. Well, that means what we're going to do is we're going to multiply by that denominator, which is 2. Well, what happens when you take x plus 2.5 and multiply it by 2? X plus 2.5 and multiply it by 2. Well, you get nice numbers. You get the other factor that I was looking for, 2x plus 5. This is the answer that should be in this blank. Y equals 2x plus 5 times x minus 1. Now, I understand that this one had a fraction in it. You guys don't like fractions. But you would just think about what number would change 2.5 into a nice number. In this case, if you doubled it, you end up getting a good value. Now, these are the types of questions that I'm asking you in section 3. Let me see if there's any more. I don't think so. We are going to have to practice the synthetic division a little bit more. In fact, let me open extra practice up for you on that, if I have it available. I know I have a video for you, and I think I have notes, but I don't know if I have a formative set up. Hold on. Okay, so this is on the extra practice page that's on Canvas, although you can just write it down wherever you, in your notes somewhere. It's just an extra practice problem. You don't have to print anything out just for this. There's this and one other one that I want to look at. So the first thing you do is, you bring that over like we talked about. So x cubed minus 4x squared. Well, come on, 4x squared minus 17x plus 60. Plus 60. Remember how I told you to move that constant over to the other side? And now we can switch to our synthetic division, right? So we're going to do that little box thing. This is where the 3 goes. Okay, we're going to hold on to that. And now we want the coefficients for the rest of the synthetic division. 1, negative 4, negative 17, and 60. Okay? And now we put the vertical line. Now we put the horizontal line with the blank space. Drop the 1 below the line. Multiply. Put that above the line. Add. Negative 1. Multiply. Negative 3. Put that above the line. Add. Multiply. Negative 60. Add. Dang, is this almost the exact same type of question we had as before? Okay, so how do I factor that? Oops, I can get rid of those last 2 things. How do I factor this? I can break this apart. I need things that multiply together to give me negative 20, that add up to. So one's got to be positive, one's got to be negative. And to add up to negative 1, I have to have a negative 5 and a positive 4. Okay, now you automatically know that x minus 3 is the other factor because I gave you 3 as an answer. So what are the answers? Of course, there's 3. and then there's -4 and +5. Those are the three solutions to that question. Okay, let's practice again. Give you a chance to finish this up. If you ever need to pause it because I get rid of it too fast, then just pause it. Whoosh, gone. All right, I want to jump down to question 13 for some more practice. Okay, so the hint that you're given here is -3 is a 0. First start by moving that over to the other side. So we have x cubed minus 3x squared minus 10x plus 24. Remember, you have to move that constant over before you do any of this. Okay. Put the -3 right in the little box and write down your coefficients. We got 1 out here, -3, -10, and 24. 1, -3, -10, 24. Okay, so we separate the last column. The reason I separate the last column, in case you're wondering, is because I want kids to realize that we get a remainder of 0. Now, eventually, we're going to do things where we don't get remainders of 0, but that's for a separate section. We carry down the 1. We multiply. And we add. And we just keep repeating. Multiply. Add. Multiply. Add. Folks, everybody on these questions should be getting a remainder that is 0. That's your remainder. Then we've got the constant. Then we've got the linear. Then we've got the quadratic. Right? Constant, linear, quadratic. Now we can think about how to factor the remaining part. So I know it's an x and an x. I need two numbers that multiply together to give me 8 that add up to -6. So that would have to be -4 and -2. So what answers do we get from this question? Well, of course we get -3. That is a definite must. But what do we get from this? 4. And what do we get from the last one? 2. Those are your three answers to this question. Okay, so we need to be familiar with graphing, and we need to be familiar with synthetic division. Okay, so that's it for our video notes on Flex Day. Have a great day. Unless you're watching this in a year when this wasn't the Flex Day video. Talk to you later.